So for this right here, here's your steps. You have to isolate the log, rewrite in exponential form. These are your steps. Then you are going to swap X and Y, and then you're going to have a T-chart, and you're going to reverse these for the inverse. Reverse for inverse. These are your steps to always graph logs and get them right. So on this step right here, this is log base 3 of X. I do not have any number in front of the log. I do not have any adding or subtracting behind the log. So step 1 is already done. The log is already isolated. So now I'm going to rewrite this in exponential form. When I rewrite this in exponential form, this is 3 to the y equals X. Now what we're going to do is we are going to switch X and Y. So this is 3 to the X equals Y. This is just our tool. We're not going to graph what happens when we plug in inputs and get outputs. We are going to swap them for the inverse, which is the log. So the first thing we need to look at is we need to notice that for the inverse, there is not an asymptote because there's nothing added or subtracted over here on the left side of my equation, which means the asymptote for my tool would have been y equals 0. So the asymptote for the log is the inverse, which is x equals 0. So I'm going to go ahead and draw this boundary line. I'm going to make sure that it's dashed. And I do have to label x equals 0. Now let's go ahead and talk about what would happen for our values if we plug them in. If I plugged in a 0 for the x value, that would be 3 to the 0, which is 1. And remember, we swap these for our inverse. So I am actually going to plot 1, 0, which is going to be the x-intercept. Now, if I plotted more ordered pairs, which I can, for this right here, if I did 3 to the first power, my output would be just a 3, which means my inverse would be a 3, 1. So I can go over 3 and go up 1 and continue to plot points. 1, 2, 3, up 1. But also you need to remember that for your domain is going to be restricted. If you see, you have a boundary right here. So the domain is going to be from 0 to infinity. But when I connect my arrows on this graph, my graph is going up forever. It's also going down forever, which means the range is negative infinity to positive infinity. So now I'm going to go ahead and take a look at number 2. On number 2, I'm going to follow these same rules. So for number 2, I know that my log needs to be isolated. I do not need to have any number in front of the word log, which would be an A value. I also do not need to have anything added or subtracted behind the log, and I don't. So I'm ready to go ahead and write this in exponential form. When I write this in exponential form, it is going to be 4 to the y equals x. So for my tool, I am going to swap x and y. So this is going to be 4 to the x equals y. So everything that I create and everything that I have a T-chart for is going to be reversed when I plot the inverse, which is going to be the log. So if you notice for the exponential form, there's not any y asymptote. I don't have anything added or subtracted right here. So I know that the inverse of my asymptote of y equals 0 for my tool is x equals 0 for my log graph. So I'm going to go ahead and graph that. I'm going to go ahead and make it in red like I usually do. So this is x equals 0. Excuse me. And again, if I plotted some ordered pairs, if I put a 0 in for x, my y value would be 1. If I plugged a 1 in for my x, my y value would be a 4. So these are all getting reversed for my inverse of my log form. So I know that my x-intercept is positive 1, 0. I also know another ordered pair is 4, positive 1. 1, 2, 3, 4, up 1. My log has a positive value. It's a positive graph. I know it's going to be up on the right. And remember, it always hugs the asymptote over here on the left. So the shape of my log is going to look something like that. Now remember, your domain has a boundary right here. It cannot go below and it cannot equal 0. So your domain is from 0 to infinity, but I have a down and an up arrow for my range. Your range can be anything, which is negative to positive infinity. I also have an x-intercept, which is going to be a positive 1, 0. All right, let's go ahead and take a look at the next part. Now, for the next part, let me get it in focus here. There's some things going on here. First of all, this +1 is not part of the log. I know it's not part of the log because it's not in parentheses like number 6 is. So what we're going to do is we're going to follow our rules. We have to isolate the log. The log is just base 2 of x, not this +1. So the +1 has to be moved over to the other side. So this is going to be y minus 1 equals log base 2 of x. Now I'm ready to rewrite this in exponential form. I cannot rewrite anything in exponential form until the log is completely isolated. So when I rewrite this in exponential form, this is log base 2, y minus 1 equals x. And then remember, for my tool, I swap x and y value. So this is going to be 2 to the x minus 1 equals y. And remember, y needs to be isolated, which it already is. So if I am looking at my exponential graph right here, I notice there is not anything added or subtracted. So I know that my tool's horizontal asymptote would be y equals 0, which means the log is the inverse of this. The log's asymptote is x equals 0. So I am going to go ahead and bold out this graph right here at x equals 0. All right, now let's go ahead and take a look at some ordered pairs using my tool right here. If I plug in a 0 here, this is going to be 0 minus 1. 0 minus 1 is 2 to the negative first power. So this would have an output of 1/2. So my y-intercept would be 0, 1/2, which means my x-intercept is 1/2, 0. Also, if you want to take a look at some other ordered pairs that would go on this graph, let's go ahead and plug in a 1. When I plug in a 1 right here, this would be 1 minus 1. It would be 2 to the 0 power. Anything to the 0 power is 1. So another ordered pair would be 1, 1. So as you can kind of see the shape of this graph, it is going to have a positive value on the right. So the shape of this log is going to look something like this.